So undersampling has its own techniques to give a good undersampling. So the key to successful undersampling is basically choosing the sampling frequency very carefully. So we always want the signal to be down converted into and centered in the first Nyquist zone, like this. So this is our signal. We want it to be in the first Nyquist zone and also centered in the first Nyquist zone. So how does a first Nyquist zone determine? It is decided by the sampling rate, half of the sampling rate. Again, the first Nyquist zone is simply half of the sampling rate. If we choose the sampling rate carefully, we can decide what the first Nyquist zone is. Alright, so assume a signal of 70 MHz with a bandwidth of 10 plus 10 plus minus 10 of 10 MHz, right? Or 20 MHz bandwidth. Okay, so this is our signal. 70 MHz plus 10 minus 10, the bandwidth is 20. Okay, let's randomly pick a sampling rate of 50 MHz. Why? Because it is at least twice than the bandwidth. So this guy is 40. I am picking something above 40, which is 50. It still fulfills the Nyquist requirement. So this value fulfills the requirement of being twice the bandwidth. So in the first case, we will have Fs plus Fm, our sampling rate plus 70, which is 120, and Fs minus Fm, which is 50 minus 70. Remember, this was the IF operation in super heterodyne. We plus and we minus the oscillator with our signal. In this case, we are plus and minusing. We are adding and subtracting our signal with our sampling frequency. So what we get is 120 and minus 20 MHz. Now, even when we have a negative frequency, it is fine because you will always get something that is mirrored in the positive side. So if this is 20, you will get it in 20 MHz as well. So no worries if you get a negative value. So this simply means 20 MHz. Okay, so our signal that started from 70, if we sample it at a rate of 50, what we would get is a signal that is down converted into 20, and our upper sideband and our lower sideband is also down converted. 80 minus 50 is 30, 60 minus 50 is 10. So this forms our signal. We have our upper and lower down converted. We have our FM also down converted into the almost in the first Nyquist zone, which tells us the sampling is okay but not the best. So how do we pick the best sampling? Let's move on. So the best sampling rate is simply to follow the formula below, whereby the sampling rate needs to be greater than 2 BW, 2 bandwidth, twice the bandwidth, and for FM over 2Z minus 1, where Z is a value that we need to find out to get the best sampling rate. So assume a signal of 70 MHz with bandwidth of plus minus 10 MHz or a 20 MHz bandwidth. So the first condition is 40 MHz. We have fulfilled this because we are using 50 MHz. Now let's solve for Z if we plug in 50 for Fs and 70 for FM. Let's solve for Z. So solving for Z will give us 3.3. Now, we need to convert Z to the nearest integer. If it is 3.6, we would convert it to 4. If it is 3.3, we would convert it to 3. The nearest round integer, or the nearest integer. So we round it off. So in this case, if we got 3.3, then our Z rounded off will be 3. So now I'm going to use this value and plug it back into this equation. So 4 times FM 2 times 3, this is z, minus 1. So I will get 4 times 70, 280 divided by 5, and this will give me 56 sampling rate. Previously, our sampling rate was 50. But from the improvement, we found out that the best sampling rate is actually 56. Now, let's try to apply this with our signal FM. So we have our signal at 70. So 70 minus 56, or 70 plus 56, I will get 126, and this guy will give me 14. Really? 46, yeah. Yes. So my signal from 70 is now down converted by 14 megahertz if my sampling rate is 56 megahertz. So it's over here. And of course, it has a 10 plus minus 10 megahertz upper and lower sideband. So those guys are coming with me, and I retained everything within the first Nyquist zone. This is the best undersampling that I can get if my bandwidth is 20 and my FM is 70. Okay. Now let's do another way to explain the undersampling is if our FM is way bigger. Just now our FM was 70, right? So let's assume our FM is 120 megahertz. So how do we do this? The bandwidth is 20. So how do we do it? So if I were to use a sampling rate that is greater than the bandwidth, 2 bandwidth, which is 40, and I still choose my FS to be 50, 120 minus 50 is simply 70, which is nowhere near the first Nyquist zone. But what happens is that it will continue to down convert until it reaches the first Nyquist zone. So 120 minus 50 minus 50 minus until it reaches the first Nyquist zone. And in the end, you would get your FM down converted to 20 megahertz in the first Nyquist zone, assuming that the values all check out. Okay, so if you have a very big frequency, FM is so big, but the bandwidth is small, you still can down convert it into the first Nyquist zone. You just minus the sampling rate multiple times until it reaches the first Nyquist zone. So let's go over an example. So a signal of 15 megahertz is sampled at a rate of 28 megahertz. So this is FM and this is FS. It's asking us what the alias is generated. So this is easy. We're just gonna FM, FS minus FM, and this would give us 28 minus 15, and this would give us a alias at 13 megahertz. So we started here. Our FM is 15, our FS is 28, right? This is FS, FM. Half of FS is 14. Nyquist zone is here. This is the first Nyquist zone. So down converting will give me something in the first Nyquist zone. Okay, so number 2, a signal of 140 megahertz has a bandwidth of plus minus, FM is 140, bandwidth of plus minus 20, therefore it gives us a bandwidth of 40. What is the Nyquist sampling rate? The Nyquist sampling rate tells us that it needs to be twice the bandwidth, therefore the Nyquist sampling rate is 2 times 40 or 80. So the answer here is 80 megahertz. Number 3, what is the alias spectrum if the 140 megahertz is sampled at a rate of 60 megahertz? Now we have to use the Fs equals to F4 FM over Z 2Z minus 1 equation, right? So here we know that the rate given is 60 and our FM is 140. We don't know what our Z is. Z is unknown, which means that I actually have to solve for Z. Okay, let's go back. So our equation is Fs equals to 4Fm over 2Z minus 1. So if I am going to solve this for Z, this would be 4Fm divided by Fs. I'm bringing 2Z minus 1 over here because it's in a bracket in itself. And then 4Fm over Fs plus 1. Right? I am left with 2Z. I will bring 2 over here, and therefore Z is going to be 0.5 4Fm over Fs plus 1. So given Fm of 140 and Fs of 60 megahertz, for question number 3, I'm trying to plug this in. 140 plus 1 divided by, this is wrong. And then we have 60 as our sampling frequency. So this would give me a value of, let me use my calculator real quick. So this is going to give me a value of 5.16 or 5. So now I'm going to plug in this Z value of 5 into Fs equation. So 4 times 140 divided by 2 times 5 minus 1. So this is 560, I think, divided by 10 minus 1 is 9. So 560 divided by 9 would give me a sampling rate that will place my Elias spectrum, Elias signal, in the first Nyquist zone. The sampling frequency should be 62.22 megahertz. Now I have not answered number 3. I don't know why I keep on skipping number 3. Let's do number 3 now. Let me duplicate this. Is the Elias spectrum if the 140 megahertz signal is sampled at a rate of 60? So we have our 140 megahertz. So 140 minus Fs, which is 60. I would get this at 80 megahertz. And since I have a bandwidth of plus minus 20, this is 110 and this is 120. So this information will also follow me when I am down converting. But now my new value, or the Elias signal, will be at 80 plus 20 is going to be 100 minus 20 is going to be 60. So this is my Elias spectrum, and this is the signal FM. This is number 3. Okay. Now we already did number 4. So how does this look like if the sampling rate is 62.22? Previously it was 140 down converted by 60, and we have this new Elias at 80. But if it is down converted by 62.22, this would give me a value of 140 minus 62.22. This means that my Elias will be at 77.78 plus 20. This is going to be 97. 9 plus 20 is going to be 97.78, and this part is going to be 77.78 minus 20 is going to be 57.78. Now, is this really within the Nyquist zone, or is it not in the first Nyquist zone? Let's try to figure it out.